And this section puts pretty much almost everything together for reals. And 3.5 pretty much sums the real and the complex, which means a review of everything. Here's the deal. In case you're wondering, how did we know what numbers to try? You know, there are an infinite amount of numbers. There's a rational zero theorem that states if a polynomial f of x, you know what a polynomial is, the leading coefficients, if those coefficients happen to be integers where the first and the last are not zero, then the rational zeros, the zeros of this polynomial, are the form the factors of the constant term divided by the factors of the leading term. So this is how I would factor almost anything. Glancing at the first problem right there, list all possible rational zeros. Well, the constant is 1, and I'm sorry, backwards. The constant is 6, and the leading coefficient is 1. So what are the factors of 6? Factors of 6 are 1 times 6 and 2 times 3. 1 is prime. Well, 1 is not prime. 1 is only a single digit. So you would say the possible rational zeros are 1 divided by 1, 2 divided by 1, 3 divided by 1, and 6 divided by 1, plus or minus. Which means if this is to factor by hand, and there is a rational factor, it has to be a 1 or a negative 1, a 2 or a negative 2, a 3 or a negative 3, and a 6 or a negative 6. How about this problem? Well, again, I need the factors of the constant. Well, the constant is 2. And the factors of 2 are 1 times 2, that's it. And the factors of the leading term, in this case, that is 1, 2, and 4. And it is dividing those by those. So if I take 1 and 2, so 1 divided by 1 is a 1. So possible rational zero or zeros would be 1 divided by each of those. 1 divided by 1 is 1, 1 divided by 2 is a half, 1 divided by 4 is 1/4, and 2 divided by each of those. 2 divided by 1 is a 2, 2 divided by 2 is 1, but I already listed that, and 2 divided by 4 is 1/2, I already listed that, so plus or minus, there they are. If this is to factor, then one of the rational factors, if it has any, would be one of those. So where are we going with this? Well, this is everything together almost except for complex numbers. Find all zeros of the given polynomial and sketch the graph. Well, let's see how this works. What are the possible rational zeros? The possible rational zeros are what? Factors of 6, 1, 2, 3, and 6 divided by 1. So there they are. Now, what's the question? Well, how quickly can you do this? Well, what are you planning to do? I want to see if 1 is a if 1 is a 0, then x minus 1 is a factor. Well, this is cubic. All what I have to do is figure out one of the zeros and I'm done, because once I reduce it by using syntactic division, I've done section 3.1, which was quadratic, and I know how to find the zeros for that. Well, let's see. Does 1 work? Well, I'm going to go for f of 1, because that's quicker than me doing syntactic division. That's 1 cubed minus 2 minus 5 plus 6. That is 7 minus 7, which is 0. Got it. What does that mean? That means if I take 1 and I do syntactic division, I'll be able, of course you could use long division if you wish, drop the first number, multiply, 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 there it is, This tells me that f of x is x minus 1. And what's left over? What's left over is 1 power less than x cubed, x squared minus x minus 6. And isn't that x minus 3 into x plus 2? So the goal is to factor. Why is that? Because I know if the zeros are 1, 3, and negative 2, this is a cubic. The y-intercept is 6, and those all have multiplicity 1. I know how to sketch a quick graph of that. So the goal is to factor these polynomials. We know about the rational zeros. We're going to try. How are you going to try? You try the remainder theorem or syntactic division until you get a 0 in the remainder. That tells you that, guess what? This factored, you reduce it, and you proceed. And not to worry if you didn't get that, because I'm doing a lot of those. Okay, and here's my second problem. Well, 36 has a lot of factors. 36, the factors of 36 are 1 times 36, 2 times 18, 3 times 12, excuse me, 4 times 9, and 6 times 6. And the factors of 7 are 1 and 7. So the possible rational zeros are what? All of these factors divided by 1, and all of these factors divided by 7. And they're all plus or minus. Now, not to worry, because the good news, most of the time, I'd say about 85% of the time, the first two integers work. And if not, 98% of the time, the third integer will work. That's how it works. Plus or minus, of course. So I need to be able to divide this. That's really the hurdle. Meaning, I need to figure out the zeros. Well, let's see. Does 1 work?